Welcome to Section 1.1, Part 1 of 3. In this section, the key concepts that we will cover is to define what is a function. We will use function notation and learn how to interpret it. And we will look at functions algebraically and numerically. First of all, what is a function? A function is a rule or correspondence between variables. It can be defined numerically, graphically, or by an equation, which we say is algebraically. We need to know the vocabulary of functions. We talk about input and output variables. The input is the independent variable, also called the domain, and you might know it as the x-axis. The output variable is known as the dependent variable. It's also called the range, or it can be found on the y-axis. In order to look at a function algebraically, we need to know an equation. In this example, we will use the formula that converts any given Celsius temperature into a Fahrenheit temperature using the equation F equals 9/5 times C plus 32. There are two variables in this equation. F is for Fahrenheit and C is for Celsius. The way this formula is written, we would say that Fahrenheit is a function of Celsius. Please note that pattern is a function of. Which variable would you say is the input? Which is the output? The input variable is the Celsius, the output is the Fahrenheit. Notice the pattern that the output variable is a function of the input variable. Using function notation f of x, because Fahrenheit is the output variable and Celsius is the input variable, we can rewrite using function notation as f of c equals 9/5 times c plus 32. Make a note of this notation. The input variable is on the inside of the parentheses and the output variable is on the outside. Also notice that the input variable c is the variable that must be used in the formula. We could also use standard function notation f of x, and we would say f of x equals 9/5 times x plus 32. Notice that we can't mix the two. I can't say f of x equals 9/5 times c plus 32 because that's not the variable that's inside the parentheses. It's very important that we learn how to interpret using function notation. So if I give you the expression f of -5 equals 23, your job is to interpret that in a sentence that can be understood by everyone. Notice that the input is -c and the output is 23. In this case, we would say that the temperature, -5 degrees Celsius, is equivalent to 23 degrees Fahrenheit. Another example of how to read and interpret functions is based on this table below here, where we have t is in years and monthly payment p of t and the cost c of t. If I ask you to interpret p of 3, you would say, well, p of t has to do with a monthly payment, so p of 3 must equal $1,096.78. Or the monthly payment for a 3-year $35,000 car loan will be $1,096.78. We can also look at a table of data numerically, and this goes back to our Celsius and Fahrenheit. Recall that Celsius is the input and Fahrenheit is the output. When we define functions numerically, we have to look at an ordered pair, and we always follow the order input, output, or x, y. And you should be comfortable identifying the input and output given an ordered pair of data. So let's summarize. What is a function? Using function notation and algebraically numerically determine a function. A function is a rule or correspondence between two variables. Please go to section now, part 2 of section 1.1.